Okay, the title of this talk is Example of Moving Goalposts, Einstein's clock mistake in his 1905 paper on relativity. Dictionary defines to move the goalposts is if you accuse someone of moving the goalposts, you mean they have changed the rules in a situation or an activity in order to gain an advantage for themselves and to make things difficult for other people. That's basically it. It's where you present an argument or a theory, then you change it. Einstein, in his 1905 paper on special relativity, makes a wrong prediction about clocks and has to be compensated for them from his 1915 theory, which was general relativity. In other words, he's moving the goalposts. What he says from special relativity is wrong, and goalposts have to be moved to general relativity. In the sense of special relativity being wrong, the clocks are not dealt with properly. Einstein wrong about clocks in his 1905 paper on special relativity was noted in Physics Today, volume 58, issue 3 in 2005. The article is called A Spool Puzzle from 1905 in his first relativity paper, and it says Einstein made one erroneous prediction. Although it should have been withdrawn when he generalized the theory to include gravity, the original error has received surprisingly little attention. So one thing to note is that Einstein made the mistake in 1905, and apparently at first it seems to be that it took 100 years to notice this error, because it was then noticed in 2005. But that observation will be amended. It's not quite true. It's more complicated than that. So this article, this article written in 2005, is supporting that mistake made back in 1905. So that's about 100 years. So this is the article. And it's pointing out the original error has received surprisingly little attention. We'll expand it and look at it in more detail. This is the article. The best known of the paradigm shattering papers published by Einstein in 1905 is Animus Miraculous, is the one titled On the Electrodynamics of Moving Bodies. That's his special relativity paper. It was there that the principle of special relativity was first set forth. Einstein asserted in his paper that time is relative. That is, if two inertial observers in uniform motion at relative velocity v were equipped with identical clocks, each would judge the other's clocks to be running too slow by a factor of v squared divided by 2c squared, and that's excluding higher order terms. Einstein immediately applied that result to a pair of identical clocks, one located on the equator and the other at either of the poles. Because of Earth's rotation relative to an almost inertial reference frame, a clock fixed at a point on the equator moves with a speed v equals 0.5 kilometers per second, while a clock at the pole is essentially at rest. Thus Einstein concluded in this first relativity paper, the equatorial clock is slower than the polar clock by a factor of 1.4 times 10 to the power minus 12. That is, the clock at the equator should lose about a second in 20,000 years relative to the clock at the pole. Einstein's comment, that's in the English translation, was thence we conclude that a balanced clock at the equator must go more slowly by a very small amount than a precisely similar clock situated at one of the poles under otherwise identical circumstances. In 1905, there was no way to check that prediction experimentally. The best timekeepers, astronomical pendulums with an accuracy of about a second per day, were hardly up to the task. Today we have cesium clocks that are up to the task. It is true that even then the interval between meridian transits of a star could be observed and calculated with exquisite accuracy, but there is no way to precisely compare that celestial interval with terrestrial clocks. Eventually, experimental verification of the time dilation effect was provided by observations of momentum dependence in the decay lifetimes of muons in 1941 and pions a decade later. Relativistic time dilation had in fact been indirectly observed in 1938 by Ives and Stilwell in the transverse Doppler effect in an atomic beam. Now, one of the things I want to comment on is I don't like the term time dilation. I would much prefer to call it clock dilation, because I think it needs emphasizing that it's not an effect on time. It's more an effect on the clocks. The article goes on, in 1907, a new consideration drastically altered the situation. With the establishment of the principle of special relativity, Einstein had turned his attention to a new problem. It seemed impossible to construct a viable theory of gravity consistent with the relativity principle. He approached the problem by formulating the principle of equivalence. The new principle conjectured that a freely falling observer in a gravitational field was equivalent to one at rest in field-free space, and that conversely an observer being accelerated in field-free space was equivalent to one at rest in a gravitational field. The equivalence principle let Einstein study the influence of gravity on physical processes even in the absence of proper theory of the gravitational field. The principle quickly led him to conclude that the relative rates of clocks were influenced not only by their relative motion but also by the difference in gravitational potential between their locations. With the advent of the full gravitational theory, with the advent of full general relativity in 1916, the effect of gravitational potential on clock rates would become precisely calculable. Thus, only 2 years after the 1905 prediction of the time dilation, which I prefer called clock dilation, due to differences in motion, it appeared necessary to make adjustments for differences in gravitational potential. Remarkably, the two effects cancel in the special case of equatorial and polar clocks at sea level. The cancellation may be seen as follows, and you can read that if you want to, but basically the 1905 prediction turned out to be wrong. I think it repeats it again here. Right. I will only point out the things that are relevant. and go to the bit where it says here, the problem with the erroneous prediction in the 1905 paper were completely unnoticed until 1913, when a collection of papers pertaining to relativity was published. It was edited by Otto Blumenthal, a mathematician who knew Einstein. The collection contained, among other things, the 1905 Einstein paper that introduced special relativity. Blumenthal indicated in the preface that the project was initiated at the suggestion of Arnold Sommerfeld and made possible by the friendly cooperation of Lorentz and Einstein. Einstein's 1905 paper appears in Blumenthal's 1913 Anthology with 5 newly added footnotes. One is of particular interest here. A footnote was appended to the sentence quoted in the 3rd paragraph of the article. Its English translation, page 50 of the Dover preprint, is not a pendulum clock, which is physically a system to which the Earth belongs. The case had to be excluded. Why this footnote was added is not clear. It's not a correct, nor does it address the issue of the correctness of the original prediction. So an update is added and still got a problem with that. So Nay points out the question was raised by Arthur Miller as to who these extra footnotes were were from, and he attributed them to Sommerfeld. But really, when you look into it, it's a bit dubious. It's not really that clear. And it goes on, it seems strange that despite intense scrutiny of the groundbreaking 1905 paper, no historian of science has ever noted, much less discussed, the incorrectness of its prediction of a rate difference between equatorial and polar clocks. There is no mention, even in the exhaustive discussion in the collected Einstein's papers. There is no record of Einstein's having corrected the erroneous 1905 prediction. So they're not noting the problem in the collected works of Einstein, and Einstein did not add a correction to his incorrect 1905 prediction as far as we can tell. In 1907, Einstein, that is, suggested that time dilation could be tested by observing the transverse Doppler effect in the light emitted by canal rays, that is, positive ions passing through canals in the cathodes of gas discharge tubes. And then it goes on. They've found 2 references to the error in the many commentaries on the paper. In April 1982, there appeared a New York Times op-ed article by Bernstein entitled Accepting Scientific Ideas. The article dealt with the criteria for distinguishing crank scientific papers from the real thing. The criterion at issue was the paper's capability of making accurate predictions. Bernstein picked out the one prediction from Einstein's Animus miraculous that was wrong. The prediction that a clock at the equator would run slower than the identical clock at either pole. In a magazine article 9 years later, Bernstein gave an accurate discussion of the cancellation between the time dilation and gravitational blue shift effects at sea level, as if he was repeating something that was widely known among physicists. In a sense, it was A discussion of the relevant physics had appeared in 1975 in a book of Problems in Relativity and Gravitation by Alan Lightman and 3 other students, Kip Thorne. So it was known in 1975 by the sound of it, but I think it's hidden away quite an obscure place in that book by Lightman and company. Now this is an excerpt from Einstein's 1943 handwritten copy of his first 1905 relativity paper, and Einstein wrote it a copy for a US war bond drive. And it goes on to say, Einstein realized as early as 1907 that clock rates increase with gravitational potential. That effect cancels the time dilation of the equatorial clock. Nonetheless, he neither omitted the sentence in the 1943 copy nor added a corrective footnote. So he was supposed to have known about it in 1907, but in 1943 he didn't correct it. But actually there is a mistake there, which I'm going to highlight a bit later on. Great. So this is the mistake. In Physics Today 58, volume 58 in 2005, it points out from a David L. Taylor, there was a sport error in that article, the article title being a sport puzzle from 1905. It says that the caption under the illustration on page 36 says clock rates increase with gravitational potential. Of course the authors meant decrease. So that refers to the thing here, which I pointed to, and it should be saying decrease instead of increase. So when it comes to trying to correct the mistakes, more mistakes are added. And here's another letter pointing out a mistake in the article. This is from Bernstein, and he was mentioned in the article, and he says, although I'm flattered by the reference to me in the article, I need to correct the record. Sometime in the late 1970s, while giving a lecture at the University of Maryland, I innocently stated Einstein's prediction about the polar and equatorial clocks. It had not occurred to me that the prediction was wrong. After the lecture, a person called Carol Ali came up to me and pointed out the error. He also gave me some reprints in which he presents the correct theory. It gives results that prove it was atomic clocks and flown in airplanes. So in the 1970s, Bernstein found out that he had made a mistake. So what we can conclude from this is physics papers seem full of mistakes. When you try to correct a mistake, you end up adding more mistakes to it. Now for the historians of physics as they input into that mess. This is a letter from Bill Shields, and he seems to be giving a historian's perspective on the reading of physics papers. He refers to the paper. And he says about the paper, the point of the article seems to be amazement that neither Einstein nor numerous historians of science have focused attention on the erroneous calculation of time dilation, which did not take into account gravitational effects. However, historians of science do not in general attempt to judge the work of scientists by the standard of later developments, which effectively means that the historians read a science paper and they don't try to correct any of the mistakes. And what they do, and if they do make a mistake, it doesn't seem to get the message across properly to the physicists, question mark. So Bill Shields then says a lot of other things which I sort of tend to disagree with. He's saying that Einstein was correct in 1905 and didn't make a mistake, and it was because it was correct in the context of special relativity. So what's the word? He said, if I go back to the bottom here, he says Einstein did not go back to correct his 1905 mistake because he had made none. So I don't agree with that. He made a mistake. Einstein made a mistake with the clocks. The clocks weren't conforming to physical reality, and to get the correct result on what the clock should be doing, Einstein had to go to general relativity. So what you were saying from special relativity was physically wrong. But Bill Shields doesn't want to see it that way. Now this is what Bernstein says. He says about it is interesting to note that in his 1905 paper, Einstein made a prediction about clock rates that is essentially wrong. He writes, this is Einstein, thence we conclude that a balanced clock on the equator must go more slowly by a very small amount than a precisely similar clock situated at one of the poles under otherwise identical conditions. That's the end of what Einstein says. If the experiment had been carried out in 1905, Einstein would have been surprised to learn that clocks go at sensibly the same rate. So Einstein makes a prediction in 1905, and if they had done the experiment then Einstein would have been surprised to find that he was wrong about his prediction. Now it goes on, but Bernstein goes on, there is the effect of gravitation that Einstein did not know about in 1905. The equator clock is further from the gravitation centre, the Earth bulges, than the pole clock, and hence the gravitational effect is smaller. If the special relativity and gravitational effects are both taken into account, the rates of the two clocks are nearly identical, which is not what Einstein predicted. In fact, all the identical clocks on the surface of the Earth run at the same rate. One can only wonder what Einstein would have made of that result in 1905. And I've got this person, Nati Rajan, who talks about it, and she says Bernstein is right to note that Einstein himself, using his theory of special relativity, got the prediction of clock speeds wrong in 1905. He incorrectly predicted that due to the Earth's rotation, a clock at the equator would run slower than one of the poles. Einstein did not anticipate his own theory of general relativity, which he would need to get it right. This would have come in 1915, i.e. general relativity comes in 1915. In a 2005 article in Physics Today entitled A Spool Puzzle from 1905, the physicists Harvey and Schuking point out that Einstein made this error by failing to take into account an effect of general relativity, positing that clocks more deeply embedded in the gravitational field would run slower. Clocks run slightly faster at the equator compared to poles because the Earth's rotation produces a slight bulge in the equator. However, the Earth is also rotating faster at the equator. These two effects compensate for each other exactly, causing clocks to actually run at the same rate in both locations. Harvey and Schuking give another explanation for why the rate of polar and equatorial clocks must be the same. They write that in the moving Earth frame both clocks are at rest, and since both clocks are at the same effective gravitational potential, they tick at the same rate. So all this is interesting, the different ways of looking at it. So getting back to the point, Einstein had to move the goalposts from special relativity to general relativity. He thought he could deal with the clocks in special relativity, then had to move the goalposts. Also, you should note that special relativity itself can be modified, which is, in other words, moving the goalposts, because different people have looked at special relativity and they make modifications to it, i.e. move the goalposts. So this is the paper. You can look at it online on the internet, and it's full of mistakes. The mistakes are left in it because it's being treated as a historical document. As per Wikipedia, it says historical documents are original documents that contain important historical information about a person, place or event, and can thus serve as primary sources as important ingredients of the historical methodology. And which I'm informed as meaning they, i.e. historians, want all the mistakes left in their primary sources. So you can go on to the go on to the internet, and you can put up Einstein's paper on special relativity, his first one, 1905, and it's been treated as a historical document, and it's full of mistakes. And since then, Einstein and others have had to move on. They've had to make modifications. They've moved the goalposts. Okay, thank you. Finn, the end.